Hi, everybody. It's Professor Mitchell. We're continuing Chapter 6. Today, we're looking at Section 6.2, which is factoring trinomials of the form x squared plus bx plus c. Remember, a trinomial is a polynomial that has three terms. And so what's special about this particular trinomial in this section is that the leading coefficient is 1. There is no other number attached to the x squared term. In the next two sections, we'll look at what you do when there is like a 2 or a 3 or a 6 there, okay? But throughout this section, it will be 1. The objectives in this section are to factor trinomials of the form x squared plus bx plus c, including when you have to start by factoring out a greatest common factor. So we're going to try really hard to always stay in the habit of looking for greatest common factor first. And we're still on SLOA, which is to rewrite polynomials in factored form in order to simplify expressions and solve equations. All right, so in our old beginning algebra course, we covered this in Chapter 5, problems like multiply x plus 4 times x plus 7. So let me switch over to my tablet really quick to remind you how that worked. All right, here it is. So x plus 4 times x plus 7, we would use FOIL. First, x times x is x squared. Outer, x times 7 is 7x. Inner, 4 times x is 4x. And last, 4 times 7 is 28. And then we would, now if we were to leave the polynomial like that, it would be really easy to factor this by grouping. But usually we combine our like terms, and in the FOIL situation, often the middle terms are like terms. So 7x plus 4x is going to add up to 11x and is going to leave us with x squared plus 11x plus 28. Notice the 11 came from 4 plus 7. It came from combining these like terms. And the 28 came from 4 times 7 when we did the last part of first, outer, inner, last. All right, so the Chapter 6 version of this problem is going to say factor x squared plus 11x plus 28, which remember was the answer to the Chapter 5 problem. And now the answer will be x plus 4 times x plus 7. So sometimes I like to say that factoring is doing a multiplication problem, sort of Jeopardy style. All right, so how can you get this answer from x squared plus 11x plus 28? Well, I pointed out to you on my tablet where the 11 and the 28 came from, right? The 11 came from 4 plus 7, and the 28 came from 4. So in general, that's how we're going to do these. They're going to hand us a trinomial. Now this only works when the leading coefficient is 1, okay? We just have to find a pair of mystery numbers to put here and here that add up to the middle number and multiply to give you the last number. All right, so to end this section, we'll just do a bunch of examples. The directions say factor each trinomial completely. If a polynomial can't be factored, then we write the word prime. So just like there are prime numbers like 23 that can only be written as 1 times 23, there are certain polynomials that can only be written as 1 times themselves, and those polynomials are called prime. Okay, so when you've tried absolutely everything that you can try and nothing works, usually that means the polynomial is prime. All right, so switching back to the tablet, and go to the first example. All right, I forgot to show you the examples, but you'll see them one by one as they come up on here. The first example is x squared plus 8x plus 15. So what's the first thing you should do in any factoring problem? you should look for a greatest common factor. All right, try really hard to get in the habit of always looking for that greatest common factor first. Now, most of the time, it's going to be like this problem. What do x squared, 8x, and 15 have in common? They don't have anything in common except 1. So most of the time, it's going to be like that. But for those other times when there is a GCF, it's really, really helpful or sometimes necessary to get that GCF out at the beginning. So here's what I was talking about. When you have a trinomial whose leading coefficient is 1, what you do is you think to yourself, okay, this is going to be x something something, x something something. The mystery numbers that are going to go in those two spots need to add up to 8 and multiply to 15. So if you start by thinking about multiply to 15, because there are only a limited number of pairs of numbers that multiply to 15. There's 1 and 15, which does not add up to 8. What else is there? There's 3 and 5, right? So I think that's our answer. And the way that you check that answer is FOIL. So let's do that. I'm not going to do it in every single example. I'm going to do it just often enough to where you will hopefully remember to do it. Every time would be the best thing. X times x is x squared. 5 times x is 5x. 3 times x is 3x. 3 times 5 is 15. And when you combine your like terms, you get x squared plus 8x plus 15. Woohoo! That's it. So the answer is x plus 3 times x plus 5. By the way, x plus 5 times x plus 3 would be just as good. The order of the factors does not matter. All right, moving on to the next example. X squared plus 4x minus 32. So same thing, greatest common factor. What do x squared, 4x, and 32 have in common? When you're thinking about GCF, you don't really have to think about the signs all that much. The important thing is, in this case, they have nothing in common besides 1. So I'm going to do the same thing I did in the last example. I'm going to think x something something, x something something. These two mystery numbers need to add up to 4 and multiply to negative 32. Okay. Now think about this. If two numbers are going to multiply to negative whatever, what do those two numbers have to be? One has to be positive, one has to be negative, right? So why don't we go ahead and just put a plus and a minus here. Okay. And it doesn't matter if you put the minus first or second. And now let's think about factors of 32. 32 actually has quite a few factors. I always start with 1 and the number, and then I take the 1 and I just keep bumping it up. So 2 and 16. 3 does not work. By the way, you can use your calculator to help you with this. Just ask the calculator what's 32 divided by 3. Comes out to a decimal, so we're not going to use that. The other possibility is 4 and 8. Now remember, we're trying to make these add up to 4 by making one of them negative. If they add up to a positive, that means it's the bigger number that has to have the plus on it. So the only way to make these pairs of numbers add up to positives would be like this. And the only one of these that works is this one right here. But since I put my plus first over there, I have to put the 8 here and the 4 there. Okay. Now, when you think about the different ways to write your answer, this would be one correct way. Another correct way would be to write x minus 4 times x plus 8. In other words, keep the minus with the 4 and the plus with the 8. It would not be the same to write x plus 4, x minus 8, because when you multiply that together, it would give you x squared minus 4x minus 32, which is not the same thing. So this is okay, this is okay, this is not okay. All right, so I'll just go ahead and box up my first answer, I guess. Yeah, we'll box up this one too. That one's fine. All right. And by the way, that's a little trick. If when you check your answer, everything is correct except for the sign in the middle, it just usually means switch your two signs and then it'll work. Signs are very important. Sometimes students think that they're kind of minor things. You know, it's like punctuation in my English essay. No. +4 and -4 are completely different numbers. All right. Yeah, so it's a wrong answer if you don't have the signs in the correct places. All right, next example, x squared minus 8x plus 16. Once again, the GCF is 1. I promise someday it will be something other than 1. All right, so now the $64,000 question is, what are the mystery numbers that add up to -8 and multiply to +16? Well, what kinds of numbers add up to a negative and multiply to a positive? They would both have to be negative, wouldn't they? And in fact, the two numbers that I can think of that add up to -8 and multiply to 16 are -4 and -4. Okay, and I thought it was important to include an example like this. X minus 4 times x minus 4 is a perfectly correct answer. However, it will make our lives a little bit easier in chapter 7 if you get into the habit of writing that answer as x minus 4 squared. So I'm going to box up that answer. Your online homework will not mark you wrong if you put it the other way. I'm just saying it'll make our lives easier in chapter 7 if we get into the habit of writing it that way. All right, let's see. I think we're about halfway through our example. So the next one is y squared minus 9y minus 18. This might be a good time to remind you. Please, 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 at any time, feel free to pause the video, try the example yourself, and then come back and compare notes. Okay. All right. Once again, the GCF is 1. Those three terms do not have anything in common. Okay, so what are the mystery numbers? Oops, let me not put that minus there just yet. I think one of them would have to be minus, but okay. All right, so these two mystery numbers would need to add up to -9 and would have to multiply to -18. So again, we had one like this earlier. If they're multiplying to a negative, that means they have to have opposite signs. And if they're adding up to a negative, that means it's the bigger number that gets the minus. Okay? So the pairs of numbers that I can think of that multiply to 18, not worrying about the signs just yet, are 1 and 18, 2 and 9, and 3 and 6. I don't think there are any others. Now you look at that 3 and that 6, and I did this on purpose. I own it. You look at that 3 and that 6, and you think, oh, that's how I get the -9. I'll just make them both negative. You see the problem with that, though? If you make the 3 and the 6 both negative, you're not going to get a -18. You're going to get a +18. Remember, in order for them to add up to a negative and also multiply to a negative, you would have to have one positive, one negative, and the bigger number would have to have the negative. So look what happens when you add up these pairs of numbers. I don't think you get a negative 9. You get a negative 17. You get a negative 7. You get a negative 3. You don't get a negative 9. So this is one of those situations when you've tried everything that there is to try and nothing works. It probably means the polynomial is prime. All right, so when I'm talking to a face-to-face class, and now I'm going to say this to you, I have a few words of caution about what you should do before you tell me that a polynomial is prime. I'm going to be looking at your written work, not always, but sometimes. You should show me something like this, like what you're looking at right now. Show me everything that you tried before you decided that the polynomial was prime, because I love to find partial credit for you. The online homework program is not good at finding partial credit. It just looks at your answer and it's either right or wrong. All right, but when I look at your written work, I'm looking for places to find you partial credit. So if you tell me that a polynomial is prime and it turns out it wasn't prime, I'm going to look at how many different things did you try. And if there were 6 things that were worth trying and you tried 5 of them, right? You tried everything except for the one that would have worked, I'm going to give you lots and lots of partial credit for that, okay? So it's kind of a good insurance policy before you write prime as your answer. Show me everything that you tried just in case it turns out that it wasn't prime. All right. Next, x squared minus 11xy minus 42y squared. So believe it or not, the GCF here is still 1. For example, x squared and 42y squared don't have anything in common. All right, so I always like to throw in an example like this every now and then because I want to show you what to do with this x squared, xy, y squared pattern. It's pretty much like the other examples that we've been doing. We're going to be finding some mystery numbers. I think I'll check this one after we get the answer just to convince you that it works. The difference with this kind of x squared, xy, y squared pattern is that the mystery numbers are going to have y's attached to them. Okay? And I'll show you. I'll show you that that works. So you take these two numbers, they need to add up to negative 11, and they need to multiply to negative 42. All right, so once again, they multiply to a negative. That means one positive, one negative. The numbers I can think of that multiply to 42 are 1 and 42, 2 and 21, 3 and 7. And if they're going to add up to a negative, oops, I didn't mean 3 and 7. I kind of got two things mixed up there. 3 and 14, and 6 and 7. All right, sorry about that. And if they're going to add up to a negative, that means the negative is attached to the bigger numbers. It has to be these pairs, and I don't think it'll take you too long to figure out that it has to be this one. Those are the two numbers that add up to negative 11. All right, so I believe the answer is x plus 3y times x minus 11y. Let's check this one because this pattern is something we haven't seen before. So just like with the other examples, you check this by foiling it. So first, outer, inner, last. For x times x is x squared. X times minus 11y is, I'm sorry, that's a typo. 14, it's not supposed to be. See, that would have come out in the check, right? minus 14xy plus 3xy. And then 3y times minus 14y is minus 42y squared. And when you add your like terms, you get negative 14 plus 3 is negative 11. So x squared minus 11xy minus 42y squared. Woohoo! Okay, so the answer, I always want to be clear about what the answer is. The answer is x plus 3y times x minus 14y. All right, last example. 3x cubed plus 3x squared minus 126x. What's the first thing you always look for? GCF. And this time it's actually going to pay off because 3, 3, and 126 do have something in common. They are all divisible by 3. And when I have an x cubed, an x squared, and an x, that means I can also take out an x. So my first step is going to be to factor out that GCF, just like we were doing in the last section. 3x cubed divided by 3x is x squared. 3x squared divided by 3x is x. And 126 divided by 3, ask the calculator, comes out to 42. The x's cancel. All right, so now I'm just going to do the same thing that we've been doing in all the other problems. See if I can come up with two numbers that add up to what? Oh, that add up to 1. There is an invisible 1 right here. So these mystery numbers need to add up to positive 1 and multiply to negative 42. Remember, we're going by after we pulled out the GCF. And the numbers that add up to positive 1 and negative 42 are positive 7 and negative 6. All right, so I'm going to leave the check on this one for you. Final answer for this factoring problem is 3x times x plus 7 times x minus 6. All right, so you should be in pretty good shape for section 6.2. We'll see you next time for 6.3.